Howdy, howdy, guys. Let's talk about the Earth and its forces. So, as we go through this, there might be some stuff that you think is very similar to science, and you are correct. You'll be learning a lot of these same facts during science class. However, we need to know some of this stuff as well because it affects the geography of Earth. All right, so let's talk about tectonic plates. So tectonic plates are these giant parts of the Earth that are massive. Okay, they are plates that are located all over the world, and they float on magma. Essentially, what we would call maybe lava, right? Very similar. It's pretty much magma. So these giant plates, they float on magma. Okay, the plates are slowly moving against one another. Sometimes they're sliding against each other. Sometimes they're bumping into each other. They are moving though. It depends on how fast they're moving. They move typically at a rate at about 4 inches a year. These plates, because they're so large and massive, when they do move or do collide, they can cause earthquakes, volcanoes. They'll eventually cause mountains to be formed, and this affects the geography around us. It affects our world. All right, so question to remember as we go through this: what causes earthquakes and volcanoes? Okay, what causes that as we go through this? Remember what causes it. Tectonic plates. Okay, so there are 4 types of movement with tectonic plates. We have what's called spreading, okay, diverging. This is when magma is floating up here. You can see the magma is floating up, okay, because of that magma coming up, the 2 plates are being driven apart, okay. As the rock cools, it sinks below the Earth's surface. As you can see on either side here, we have a continent and another continent, the ocean in the middle there, and these oceanic crusts, because the magma flowing up, they're being driven under the continent. So we have spreading, we have diving. This is when a plate hits a bigger plate essentially, and it forces it under it. Okay, imagine a Ferrari flying at 100 miles an hour. If it hits a semi, okay, if it hits a semi, who's going to win? The semi. Okay, the semi is much larger, it's much bigger. What vehicle will end up on top? The semi. Okay, similar situation here. We have a thicker crust and a smaller crust colliding, and when they collide, the bigger one is going to win. All right, so this is called diving or converging. It's an example of it there. We have colliding. Okay, this is similar to the car, except this time imagine it's 2 semis hitting each other. These 2 semis are so big, their forces are so great that neither one's going to go under, they're going to go up. Okay, so we have these 2 massive plates that are colliding against each other, and the force is so great it causes them to go up. And this is how we get a lot of mountain chains to form, is because of this colliding. So when you look at mountain chains in the Himalayas, all over the world, typically they are caused by 2 tectonic plates colliding. There are some mountain chains where we're not entirely sure what happened, but there are some theories to those. All right, we also have sliding. Okay, these 2 plates are next to each other and they slide past each other. When they slide past each other, they're grinding next to each other. That's going to cause friction. It's going to create a fracture in the crust. This fracture in the crust can look like this. Okay, this is the San Andreas Fault. You may be familiar with it. There was a movie about the San Andreas Fault it's called San Andreas, starring The Rock, right? So, what this can cause? Earthquakes. This will definitely cause earthquakes. So a famous example would be out in California. There are lots and lots and lots of earthquakes in California. Most of them are very small, and most of them are not very serious. But every so often they get a really big one that's really bad. Okay, so here we have, you have sliding, converging, diverging. We're missing one. We're missing the colliding. Okay, but those are images of it. All right. There's a video for you. Now let's move on to the 5 layers of our big cake, the Earth. The Earth is made up of 5 big layers. Now what's interesting about this is no one has ever been past the first layer. Okay, no one's broken through the crust. So when we say there's a crust, mantle, outer core, inner core, all right, an atmosphere, no one's ever dug deep enough down to actually reach the core or the mantle. So there's a lot of science that leads us to believe that this is accurate, but again, there could be something else down there that we're not entirely sure about. But the best science shows us that the Earth is made up of several different layers, and we're going to learn about that right now. At the very inner core of the Earth, it's called the inner core, the first layer, inside. It's solid iron and nickel, okay, and it is hot, very, very hot, thousands of degrees. Outside of that, we have what's called the outer core, okay? The outer core is a little bit bigger than the inner core. It's made up of liquid metals, and it's about 1,400 miles thick. Okay, so it is it's very thick. All right. To put it in perspective, the deepest we've ever dug down into the Earth, I don't even think it's 12 miles. I want to say it's 12 miles, but that's not right. We have not gone very deep. Okay, so next, outside of the outer core, we have what's called the mantle. The mantle is incredibly thick. The mantle is almost 2,000 miles thick. Not quite, but it is almost 2,000 miles thick. You can break up the mantle, but we're just going to say it's the mantle. The mantle is also incredibly hot as well. And this area is going to be filled with lots of magma. Okay, and these giant tectonic plates that our continent sits on or other continents sit on, they are floating on this magma that is made up of the mantle. Next and lastly, we have, not lastly, but we have the crust. The 4th layer is the crust. Imagine a pizza crust, right? That is where we live on. We live on the crust, okay? The crust is about 20 miles thick. We have never dug through the crust. There are parts of the crust that are thinner. There are also parts of the crust that are thicker. Okay, just like your pizza, right? You get thin crust, sometimes you get pan, sometimes you get thick crust, right? So there are different parts of thickness throughout, but regardless, we have never dug through the crust. We've never been down that deep. All right, our final layer, our 5th layer, is the atmosphere. It's a layer of gases, including oxygen. You can break up the atmosphere into smaller pieces like thermosphere, mesosphere, stratosphere, troposphere, but we're just going to call it the atmosphere, okay? Now, this is where obviously oxygen is at, and that is incredibly important because we need that to survive. So, those are the 5 big layers. That is incredibly important. It affects our daily lives. All right, we're going to stop here for the day.